Hello, stat students. Last time we talked about displaying quantitative data in various ways. We learned how to make dot plots, stem plots, histograms, and box plots. Today we are going to compare the mean and median and see which one is better to use when. In symmetric distributions, the mean and median are roughly the same. In that case, when it's symmetric, when the distribution is symmetric, it is more powerful to use the mean because it tells us a lot more about our data. In skewed distributions, however, the mean is pulled towards the tail. In skewed distributions, it's better to use the median. Identify which value is the mean and which value is the median. So you have the green triangle and the red one, and you have to tell which is which. So the first thing we want to do is draw a density curve over a graph. If you look at this, the tail is towards the right, so it is right skewed. And when a distribution is skewed in either direction, the mean is pulled towards that direction. So in our case, the green triangle would be the mean, and then the red one would be the median. The mean is greater than the median in a right skewed distribution. For the second graph, the tail is to the left and the mean is pulled towards that left. So the mean again is the green triangle. Its value is less than the median, which is the right triangle. So to recap, when distributions are skewed right, the mean will be greater or larger than the median. When distributions are skewed left, like the right picture, the mean will be smaller than the median. When distributions are symmetric, the mean will be the same or equal to the median. What is the best measure of center and spread? Well, it depends if your data is symmetric or skewed. So if your data is symmetric, we are going to use the mean for the center and the standard deviation for the spread. If our data is skewed, then we're going to use the median to represent our center. And when we're going to use the interquartile range, IQR, to represent spread. And what if there are outliers? Well, if there are outliers, we are going to use the median and the interquartile range. And the reason we want to use those is because they are resistant to outliers. If we have a really large or really small value, because the IQR is at 50% in the box, it's not going to be affected by extreme values. Same with the median. Kind of like one of the homework questions. You have these people at a company, and 5 people make $22,000 a year, and then one person or 2 people had 60,000. Then you had a $270,000 salary. It didn't affect it, like changing. It didn't affect the median. So they are resistant to outliers, and they are a better measure of center and spread. that brings us to our first question. Who has more contacts, males or females? The following are 5 number summaries for the number of contacts that a sample of high school students had in their cell phones. Describe what these values are telling you. Are there any outliers in either distribution? Well, we've done this problem before, and I remember, so no. We calculated this earlier, sorry. I can't spell today, so I guess it doesn't matter when you teach math. You don't have to be a great speller. Okay, based on the numerical summary, what shape is the distribution of males? So we want to compare the mean versus the median. So for males, the mean is 122.15. The median is 109.5. So the mean, let me just write that down. X bar is 122.15. Median, capital M, is 109.5. Since the mean is greater than the median, this is a right skewed distribution. Okay, let's do the same comparison for the females. The mean is 126.71. The median is 129. So the mean is 126.71. The median is 129. Very close, but the mean is less than the median. This is a left skewed distribution. You know what? I think I should put the word slightly. Because those numbers are still pretty similar, but one is definitely a little smaller than the other. So I wanted to put the word slightly in. And then lastly, comparing the distribution. So let's always want to make sure we get those involved. So probably need to write small here to fit everything in. The distributions are definitely skewed. So we can just say they have different shapes, but we want to be specific. So males are right skewed, while females are slightly left skewed. As far as the center goes, the females have a higher center. The median, almost forgot what I was using, 129 versus 109.5. Okay, and then now we also want to look at these numbers, because if we're going to use the median, we want to use the IQR to measure spread. So subtract those two and then subtract 180 minus 83. So the first one is 103, and for females, it's 97. So the males have males have a slightly larger variability. IQR 103 versus 97. And lastly, neither distribution has outliers. You know, when you're writing, you can always do shorthand. These are your notes. But for certain symbols, don't take a shortcut. And you will get docked for that on any kind of exam. Okay, finishing up our very last page, we have some sample problems. This comparing distributions, address all four characteristics, so socks, and use comparison phrases like about the same as or much greater than. Compare the distributions for the cities. So we are probably going to be interested in some numbers, and since we don't know individual values, it's best to use the mode for our center, and then therefore for our spread, we should use the range. So we need to know this number, 77. This is 102. Our peak right here is 88. Okay, and then looking at the bottom graph, this value right here is 57. Our peak is at 68. This number right here is 82. They both look pretty symmetric to me. So as far as describing goes, I'm just going to write all over the place. So both distributions are symmetric. Let's talk about the center. City A's center is higher than City B's. So mode 88 versus 68. As far as the spread goes, let's calculate the range. 102 minus 77 is 25. 82 minus 57 is also 25. So both cities have the same spread. Range is about 25. And lastly, both have no outliers. And we're done with that one. Okay, let's look at our next one. Clearly left and right skewed and left skewed graphs. So if we look at this one and label it, this value is 76. This is 99. It's okay to be off a little bit. This one's 85. This one is 58. And our peaks are 84. And so this is 84. And this is 78. So I think we have everything we need to go ahead and talk about our distributions. So city F is right skewed, city G is left skewed. City F is right skewed. while city G is left skewed. City G actually has the higher mode, the higher peak at 85, or I'm sorry, at 84. So the peak is at 84, the smallest value is at 85. So city G has the higher center, 84 versus, oops, I did it again, mode 84 versus 78. And then let's look at the spread. City F has a range of 23 and City G has a range of 27. So pretty similar. So City G, oops, I wanted to write the letter G there. So City G has a slightly greater spread. Range 27 versus 23. City G has a possible outlier while City F does not. I mean, I'm going to say possible. Don't know for sure. Can't calculate without lots of real numbers. So City G has a possible outlier while City F does not. Done with that one. All right, last but not least, comparing box plots. We do it very similarly, but at least the values are pretty easy and right there. So looking at this is the male and females. So a group of students investigated their belief that females text more than males. They asked a random sample of students from their school to record the number of text messages sent and received over a 2-day period. Here are the box plots. So you have the 5-number summary for each one. The median for males is 23. Gosh, that's hard to read. And 2 outliers, these 2 dots over here, 213 and 214 are outliers. Q3 is 83 and Q1 is 6. So let's over here, 83 minus 6, that's 77. And for the females, it's 191 minus 34, which is 157. Wow, that's a big difference there. And honestly, we can just describe the distribution based on what we have there. Females is rather right skewed. This one is not as much, but it's still skewed right. So both distributions are right skewed. Females have a higher center. Median is 107 versus 23. Females have more variability. IQR 157 versus 77. And lastly, males have 2 outliers at 213, 214, while females have none. right, in our very last example for this first chapter, we're looking at the split stem back to back stem plot. So these are the male and female heights in centimeters. And we've looked at this plot before too. So if we were to draw this, it looks, if you were to draw a density curve over here, oops, didn't do that good of a job. It's pretty uniform. I mean, you have these two numbers in this, two, two. So you can go either one. I'll probably just use symmetric. And if you look at the females, now you have to remember if you draw that over it, it's not right skewed, it's actually left skewed because remember, this is the smallest. So if you were to write it out and make it look like a dot plot, you'd only have three numbers going up and then five. So it's actually left skewed, even though you're drawing it that way. You just kind of have to visualize it a little bit differently. So males are symmetric, while females are left skewed. Now, what I did here to save time is I entered all these in a list and then I had it calculate the median, the Q1, Q3, because I was not about to go and cross numbers out to find what the middle was. This is when you really want to have a graphing calculator handy because you have so many data values. So males ended up having a higher center. I calculated it, and the median was 167 versus 162. Okay. The males also had more variability. So the IQR for males was 16 versus females, which was 8. And lastly, both have no outliers. And what I did was I also, after I entered in the data, I looked at the box plot and noticed that did not have any outliers. And that is it for chapter 1. Have a great day, stat students.